So we've been looking at linear growth and exponential growth, and what we want to do now is look at linear and exponential decay. So in other words, the values are going to be decreasing. So I'd like to refer you back to this page that has this nice table. And when we have linear decay, we're looking at decreasing by a fixed amount. So you're going to see a negative rate of change or a negative slope, which is going to cause the outputs or the y values, however you want to think of it, to be decreasing by a constant amount. When we have exponential decay, that means we're going to be decreasing by a fixed percent. So we've talked about percent increase and percent decrease. So you remember in the examples that we just did, if we had a percent increase, then we would want to add that percent to 100% to create our multiplier. If we have a percent decrease, then we're going to want to subtract that percent to get our multiplier. So for example, we did one in a last activity where we were increasing by 12%, which is 112%, and our multiplier was 1.12. If, for example, we had, say, the value of a car was decreasing by 12%, then we would want to subtract 12% from 100%, and the value of our car would be 88% of the previous year's value. So our multiplier is 0.88, and that's what we're going to see when we're doing exponential decay. All right, so your multiplier when you're doing exponential decay is going to be some number between 0 and 1. Right? 0.68, 0.75, 0.12. That would be quite a decrease. You'd have an 88% decrease if you're doing 0.12. If you're doing exponential growth, your multiplier is bigger than 1. Let's go take a look at activity 3. Number 1, suppose you have a loan with an outstanding balance of $1,200. You make payments on the loan so that your balance decreases by 7% each month. Hopefully you're thinking about the multiplier. If your balance decreases by 7% each month. Okay, we'll get to that. A, does your balance decay linearly, exponentially, or neither? Take a pick. Is this linear, exponential, or neither? Hopefully you're saying exponential. Whenever we're decreasing by a fixed percent, we have exponential decay. Decrease by a fixed percent. Now it's not going to be a fixed amount. It's going to be decreasing by a different number of dollars each month, but it's going to be decreasing by the same percent each month, and that's exponential decay. All right, let's complete the table. You need your multiplier to complete the table. You got it? We have 100% of our balance, but we're going to decrease that balance by 7%. So each subsequent month, the balance will be 93% of the previous month, and so the multiplier for 93% is 0.93. All right, so we're going to multiply by 0.93. Go ahead, pause the video, fill out your table, and start the video when you are done. So hopefully your table values look something like this. So we can see our balance is decreasing each month. C says, what will your balance be after 2 years and 5 years? So this is kind of like adding to your table. We could expand our table here. Don't have enough room, but we'll squish it in here. So after 2 years, how many months is that? 2 years is 24 months. And 5 years, how many months would that be? Well, that'd be 5 times 12 months per year is 60 months. So this is really the question we're asking, is what would these values be? So again, let's think about the equation. All right, we're repeatedly multiplying by 0.93. So our balance, it doesn't ask us for the equation yet, but let's fill it out. Our balance started at $1,200, and then what are we doing? we're multiplying that by 0.93 over and over and over and over again, however many months. So this is going to be to the m power, or whatever variable you want to use. I'm going to use m for months and b for balance. So one way you could think of getting the value, the balance after 4 months is you could think, well, I started at $1,200 and then I multiplied by 0.93, 0.93, 0.93, 0.93. So I did it 4 times. And if you punch this into your calculator, you're going to get $897.66, which is the same thing you should get if you just took 1,200 times 0.93 times 0.93 times 0.93 times 0.93. So for 24 months, we're going to take our balance is going to be the $1,200 times 0.93 to the 24th power. For 5 years or 60 months, our balance is going to be our starting balance times 0.93 to the 60th power. All right, go get those numbers. Let's see what we have for our balance. After 2 years or 24 months, you should have a balance of $210.27. And after 5 years or 60 months, you should have a balance of $15.42. Do you think this is an efficient way to pay off your balance? What do you think? I mean, it seems like after 5 years we should have this thing paid off, right? I mean, that doesn't seem like... Why do I still owe money after 5 years? It was only $1,200. I want to write one more thing up here just to highlight kind of what's happening. So for our balance for 60 months, we had $1,542. What if I had 61 months? Okay, let's go to the next month. So we could take 1,200 times 0.93 to the 61st power. We could do that. Or we could multiply $15.42 times 0.93. Either one of those things is going to work. I'm just going to punch in 1542 times 0.93. So my next month's balance will be $14.34. Do you think this is an efficient way to pay off your balance? This is like $1. You know, once you get down to this amount of money, $15, you're taking 93% of a relatively small number. You know, 93% of $15.42 is $14.34. So you'd only pay 7% of $15.42 is only a little more than $1. That doesn't seem like a great idea. Remember, you're taking 93% of a progressively smaller and smaller number, so you're really paying off a smaller and smaller amount each time, each month. And you could see that by subtracting these two numbers right here. All right, so if I subtracted these two numbers, I'd have about, what, $84? So that would be a payment of $84. If I subtracted these two numbers, let's see, 1,037.88 minus 1,116, or I should have done that the other way. It's going to be negative, but do it the other way. It's going to be $78, which is less than the amount that I paid last time. And if you kept subtracting these, it would be a smaller and smaller and smaller amount each time. That's really not how you want to pay off your balance. Much better to pay it off in a linear fashion, right? Much better to pay, say, $100 per month. What if you paid $100 per month? So this would be linear decay because we're decreasing our balance by a constant amount of $100 per month. Well, if you're starting with $1,200, it's only going to take you 12 months to pay it off. It would be paid in 12 months. Much better way to go. As opposed to if I do exponential decay, it's 5 years later and I still don't have it paid off. And if you think about what this graph would look like, it's going to look something like, well, let's go do the graph. Let's go do the graph on Desmos. So we would have our balance. We were starting with $1,200, and then we were multiplying that by 0.93 to the power of t. Okay, I gotta change this. So when you have exponential decay, you get a drop here, but then it's less and less of a drop each time because you're taking 93% of a smaller and smaller number. So technically, it's never really going to get to 0 because you're taking 93% of the number before. So you're never paying it off. You're always having a balance. So that's what this graph of exponential decay is going to look like. It approaches 0, but it never actually touches 0. So not a good way to pay off your balance because it's never going to get to 0. As opposed to linear, it will get to 0. All right, let's look at question number 2. A water pump leaks water at the rate of 1.3 cubic centimeters per minute. Does the volume of water decay linearly, exponentially, or neither? Pause the video, write your answer, or just write it if you have it. So the key here is the rate is 1.3 cubic centimeters per minute. 1.3 cubic centimeters per minute. And it's leaking at this rate. So really, we're losing 1.3 cubic centimeters per minute. So that is going to be linear decay. Linear because we're losing the same amount of water each minute. It's a constant rate of change. And decay because it's getting less. The amount of water say it's inside of something. It doesn't really say it's inside of a tank or something, or the total amount of water that we're losing would be represented by this negative amount. This does kind of highlight the fact that it depends how the question is worded. I mean, if we did have some kind of a tank and we were looking at the water that was in the tank and it was leaking at this rate, then we would be losing water out of this tank at 1.3 cubic centimeters per minute. If we wanted to know how much water we had, let's say it was leaking out into this other pond or something like that, and we wanted to know how the volume of the pond was increasing, or say some catch all that caught water that was leaking. The water in here is actually increasing by 1.3 cubic centimeters per minute. So we don't really have a lot of context here to tell if it's decay or growth, but I guess from our choices it says, does the volume of water decay linearly, exponentially, or neither? So if those are our choices, we would say linearly. But again, depending on the context of where the water is, what's happening with the water, you could make an argument for decay or growth. But we certainly have a 1.3 cubic centimeter per minute change in the amount of water, which is constant and therefore linear.